Welcome back, Recruit. In this lesson, we're going to be discussing control flow basics. Control flow allows us to add logic to our code. It allows us to also specify under what conditions we want certain blocks of code to execute. To do this, we use the if, elif, and else statements. Now, in order to show the syntax for these statements, we need to quickly discuss comparison operators. Comparison operators allow us to compare two different objects. Typically, for these examples, we'll be using them with numbers, but you can use them with a variety of data types. Here we can see the symbols as well as their associated meaning. These should be pretty straightforward. Things like greater than or equal to, greater than or equal to, and then if you want to check if two objects are equal to each other, you can use two equal signs for equality, and then an exclamation mark and an equal sign for not being equal. Now that we know that, we can understand how control flow is going to use Boolean conditions to decide whether or not to execute a block of code. Recall that Booleans are either true or false objects, and comparison operators that we just saw will always return a Boolean value that we can use for control flow. So let's go ahead and see some examples of control flow. The control flow syntax makes use of colons and indentation, otherwise known as whitespace. This indentation system is crucial to Python, and it's really what sets it apart from other programming languages. Indentation results in more readable code, and it also forces a programmer to organize their code as they program. And this is one of the main factors in Python's quick rise to popularity. Let's explore some syntax examples for control flow. This is the syntax of an if statement. We will say if, and then check for some condition, and then have a colon. And then beyond that colon, we'll have an indented block of code where we can execute it if that condition happens to be true. For example, we can say if 1 is less than 2, print this is true. And if we were to run that small block of code, we would get out this is true since 1 is less than 2. We can add on an else to this statement. We'll first check if some condition is true, and if that condition happens to be true, we'll execute some code. However, we can also specify some other condition to execute if that condition doesn't happen to be true with the addition of the else statement. And notice the indentation lineup here. The else is associated with the same if statement above it because their indentation lines up. And that's how Python is able to understand what blocks of code relate to other blocks of code. It uses indentation to understand that. Let's go ahead and actually put an example here. We can say if 1 is equal to 2, print whoa, else print everything normal. And when you were to run this block of code, you should see everything normal because 1 is not equal to 2, so that block of code doesn't execute. So then we go down to the else statement. Finally, we can add in elif statements in order to check for other conditions that are not in the if statement. That means we check for the original if statement, if 1 is equal to 2, print something or execute some block of code, and then we can have multiple elif statements below it. And this can check for any number of other cases that are specific that we want to check to see if that condition is true or false. And if all of those fail, then finally we have our else statement. Notice how there is no condition on the else statement because it's only going to execute if everything above it happened to be false. And in this case, we can go along the code and see 1 is not equal to 2, so we don't print out whoa. The second block of code is true, 1 is equal to 1, so then we print out 1 is equal to 1, and that basically ends this entire block of code. The else will only get executed if everything above it is false. Keep in mind the indentation when utilizing control flow. Poor indentation can lead to mistakes or bugs in your code. Let's explore these examples in actual practice and see how we can program using control flow. Let's begin by coding out a simple example illustrating what we just talked about. We'll say if 1 is less than 2, colon, and then notice when I hit enter here, Jupyter Notebook and many other Python IDEs will automatically create the indentation for you. And then we can say print condition met. And when I run this, notice I get back condition met. If I were to reverse this, asking if 1 is greater than 2, print condition met, I don't get out any output because this block of code will only execute when the condition here happens to be true. And keep in mind, it doesn't have to be a comparison operation. It could just be something like true. So we can say if true, print condition, or we could say if false, nothing's going to happen. typically you're not going to see a straight Boolean here. Instead, you may see an assigned variable. So you may have something like COND for condition, say 1 is less than 2. That's our condition right there. And then we'll say if condition, print con met, and then we see con met. So when you're reading someone else's code, more likely than not, there's going to be some sort of variable here or some sort of variable comparison. That's the basics of the if statement. Let's quickly discuss the if-else statement. And now we can add in an alternate action in case that first if statement doesn't actually end up having a true condition. And really take notice of the indentation and how the blocks are lining up here. We'll say if 1 is equal to 1, print condition met 1 equals 1. And then I'm going to line up an else block at the same indentation level of this if statement. And notice I don't have any condition in the else block because the else block, its job is to execute only if all the other if checks above it happen to not occur or be false. So then we'll print last block happen to run. We run this and we say condition met, 1 is equal to 1. If we were to change this so that it was something false, like 1 is equal to 1,000, and then I run this, it says last block happened to run because this if statement didn't execute, so then we see the else execute. If we want to check for more than just one condition, we can have the elif statements, so that allows us to check for multiple conditions. Let's give an example of this. We'll say if 2 is equal to 0, we'll print first condition true. And then we're going to check for an additional condition. And here we can actually have a condition to check. So we'll say 2 equals 1. And here we'll print second condition true. We'll have one more. We'll say else or elif 2 is equal to 2. Print out third condition true. And then finally we'll have an else saying nothing above was true. So there we have if, and you can have as many elif statements as you want. And if we run this, we get back that the third condition was true because 2 is not equal to 0, 2 is not equal to 1, but 2 is equal to 2. And the else doesn't occur because it only occurs when all the matching up blocks of elif or if conditions happen to be false. Now notice what happens if we end up having multiple conditions in a row that happen to be true. So we'll say 2 is equal to 2 up here, as well as elif 2 is equal to 2. So here we have two true statements. And if you run this, what ends up occurring is you only end up executing the first true condition. So keep that in mind. This third one here, even though the condition it had was true, the way Python works is it's going to keep going up until it finds that first true condition. Let's work out one final example that is a little more practical. We will create a variable called agent code. Go ahead and just give this some number. Doesn't matter what number it is, it can be random, and we'll set up access is equal to the variable false. So we have an agent's code and some sort of access parameter. And then we'll write some blocks of code here to check if the agent code matches up. We'll say if the agent code is equal to 1, 2, 3, 4, 5, we will print out code reset, and then we'll also print out call a supervisor. That's the first condition we'll check. Then we'll actually check to see if we have a matching agent code. We'll say if agent code is equal to what we wrote above here, I will just go ahead and copy this. Then we'll print welcome agent, and I'll just pass in that number there. And I will say access is equal to true. So note what I'm doing here. I will actually be reassigning a variable only on the condition of this agent code matching up. And then finally, I'll have an else statement here that says print sorry, no matching code. And then further down in this block, I can actually create some other set of control flow logic. So I'm going to put a bunch of hashtags here as comments to kind of separate out this other block here. You don't need to do this, but it's just for visibility. We'll say if the access code is equal to true, print access granted. And then we'll say else, print access, access denied. Okay, so let's see what's actually going to happen before we run this. We have an agent code, and we say access is equal to false. So Python is going to go along. It's going to check, does the agent code equal 1, 2, 3, 4? Well, it does not, so it won't run this block of code. Then it's going to check, does the agent code equal this number? It does. So it will say print welcome agent, and then it's going to reset access to be true. Then else is not going to execute because we had something true up here. And it's going to keep going down. And here we can see we've now said and started another block of if-else statements. And the way Python knows that this block up here doesn't have anything to do with this block down here is because we've essentially closed off this if statement with an else statement, leaving us open to start up a new if-else statement. So let's run this and see what happens. We get welcome agent 23192, and then we also get access is granted. Because we had an additional check here, access is equal to true, print access granted. And we could actually, if we wanted to take a look at this last set, we could split up this one into a new cell itself, or a new piece or another script if you wanted to. And now let's see what's going to happen here. So we say, if we run this code, it says welcome agent 23192, and if we run this here, it'll still say access granted. Let's rerun this with 1, 2, 3, 4, 5. We'll run this cell again, and now it says code reset, call a supervisor, and if we run this again here, since access was equal to false, and we never actually reassigned it in this block, because we instead ran the code reset block, when I run this last cell, it will say access is denied. The last point I want to make here is if you already know that your variable itself is a Boolean, either true or false, so for example, if I just ask what access is, it's going to be false, or if it happens to be reassigned, it will be true, you don't really need to make this comparison because access itself is already a Boolean. And this is a typical example of being able to differentiate someone who's just learning Python to someone who's a little more experienced in Python. This sort of code right here indicates someone who's not very experienced in Python, because a more experienced developer would have realized that access itself is already a Boolean, meaning they could have just done this. They don't need to check if access is equal to true, they just need to check the access variable itself. So this is how you're going to see more experienced developers write their code. They will say if access, print access granted, else print access denied. And this code, you can see we reran it again, works exactly the same because access itself is the actual Boolean variable. So writing code like we just did is a little bit cleaner. And it also allows you to name your variables differently to make it even more readable. So we could have renamed access to be access underscore granted. So then it could say if access granted, print access granted. All right, excellent work so far. Now that we understand control flow, we can begin to build an understanding of loops. Coming up next.